Hey guys, we're going to talk about inverse trig today, so this is all stuff that you've done in pre-calculus. But before we can talk about inverse trig, I want to make sure that we recognize this, and we know sine of theta. If you think about your triangles, sine of theta is equal to the opposite over the hypotenuse. So that's regular trig. Inverse trig is what happens when we undo that. So instead of saying, well, I have this angle, what's the ratio between the opposite and the hypotenuse, I'm going to say, well, I have this ratio, so what is the angle that gives me that ratio? So really what you're trying to figure out, this is what it would look like, this is inverse trig, but that means that I have the sine of some angle theta equals opposite over hypotenuse. It's just two different ways of writing it. So for instance, if I have the inverse sine of 1 over square root of 2 equals theta, that is the same thing as asking, okay, well, if I have sine of theta, and I know that it equals 1 over the square root of 2, then what was my theta? And because I remember my triangles and my unit circle and everything, I know that theta has to equal 45 degrees, or pi over 4 radians. And it could also equal 3 pi over 4. Okay, so that's the basic. All of the functions work like that. The problem is when you look at your calculator, it's only got inverse sine, inverse cosine, and inverse tangent. But we have 6 trig functions. So when we're going to plug this in our calculators, inverse sine, cosine, and tangent are easy. When you have inverse cosecant is when it gets interesting. So if you remember cosecant, normally the ratio that goes with cosecant is the hypotenuse over the opposite. So it's related to sine, because it's just the reciprocal. But the way that I want to plug that into my calculator, I need to use the sine function to do it. So I need to figure out, how is that related to sine? So remember, we don't really care what we're plugging into the calculator as long as we get the right angle out. So if I've got this ratio of hypotenuse and opposite, well, there's no reason that I have to do it as hypotenuse over opposite. I could flip the ratio over and do it as opposite over hypotenuse. Then when I do that, opposite over hypotenuse is just sine, so now I can use inverse sine, and that'll tell me exactly the same angle. So these two angles are the same. They're equal to each other. So instead of doing cosecant in the calculator, I can do inverse sine. And then same thing with inverse secant. That's related to cosine, because it's the hypotenuse over the adjacent. So I can change it to cosine, and all I have to do is flip the ratio over hypotenuse, and that will give me the same angle both ways, except this one, the bottom one, I can type into the calculator. So I'm going to show you an example of that before I talk about cotangent, because that's a little different. So for instance, if I have let's say I have the inverse cosecant of, let's think of a good ratio, of 2. And I want to plug that into the calculator. Well, I can't type it in as inverse cosecant. So what I need to do is change it to inverse sine, and I have to flip the 2 over. So I'm not going to write the 2 upside down, obviously. So flipping it over means taking the reciprocal, so I'm going to write 1/2. And then when I type that into the calculator, it'll give me my answer, which I should know off the top of my head, but it's really hard to record a video and think about trig functions. So the inverse sine of 1/2 looks like this. 0.5236. Alright, hypotenuse and opposite, or I guess that would be 30 degrees, so that's pi over 3 radians. Oh, sorry, pi over 6 radians. Okay. Either one of those answers is okay on the AP test, by the way. Alright, so same thing with secant. If you want to use secant in the calculator, you just have to take the reciprocal of whatever your ratio is, because then that'll switch it to the other operation. But the problem is with cotangent, you can't, well, you can do that in most cases, but sometimes the calculator doesn't really deal with it very well. So let's talk about how to deal with inverse cotangent real quick. Alright, so inverse cotangent, this is the problem. It looks like it should just be, you take tangent and flip it over, but you really can't. So right here, cotangent is adjacent over opposite, which is related to tangent, but we can't do it that way. So if you remember this thing too, cotangent is also equal to cosine over sine. The calculator deals with that a lot better. So this is what we're going to relate inverse cotangent to. So instead of typing in inverse cotangent of whatever your ratio is, we're going to do inverse cosine of the ratio over inverse sine of the same ratio. And that is the same as cotangent, inverse cotangent. So they will give you the same thetas. This way just works a lot better than using inverse tangent does. So I would try to avoid inverse tangent. Alright, and I also wanted to point out that on page 51 in your textbooks, this is the next part that's coming up. So page 51 has the inverse graphs, and that's what we're about to talk about. But I just wanted to tell you that so you don't have to draw them. They're in the textbook. Okay, so that is the next part. Alright. Inverse trig graphs. Alright. So for our inverse trig graphs, we're going to start talking about regular trig functions first. So like y equals sine of x. This is a graph that you need to know what it looks like off the top of your head, because at some point on the AP exam you're going to have to do this without a calculator. So I know 2 pi and pi are my zeros. It goes like this. And I'm going to go ahead and draw it back this way a little bit, so this is going to be negative pi here. Okay, and I know that my amplitude is 1 and negative 1. Alright, so the domain for this, I'm going to list everything out because it'll make it a little bit easier to see what the inverse is. The domain is all the x values I can plug in, so that's going to be all real numbers. X can be whatever I want it to be. The range is going to be the lowest y value to the highest. You guys know this because you're in calculus. Alright, negative 1 to positive 1 is our range. So when I do the inverse, what's going to happen is that the x and the y basically switch places. So really, your input and your output switch. The notation's going to look a little bit weird because I'm not going to switch the x's and the y's. But when we graph our inverse function, it's reflecting it over this y equals x line. So if I draw a little line in here, y equals x, the reflection of that is going to be the graph of my inverse. So we're taking sort of a mirror image of it. But the problem is if I do that, you might be able to picture it in your minds. If I take this part and I flip it up here, I'm going to get something that's sort of shaped like this, but only much better drawn than that. But the problem is that's not a function because it definitely doesn't pass the vertical line test. So that's not our inverse. But we have to have an inverse because we have to have a way to go backwards. So what they do, you may remember this or maybe not, is that they limit what the domain is. So instead of saying that the domain is all real numbers, now what we're going to do is change it so that it's not all real numbers. We're going to say, okay, well, we're just going to look at the domain from negative pi over 2 to pi over 2. And the reason that we're choosing that is because this is pi over 2, right here. And this drawing is going to get really messy. This is negative pi over 2, and then positive pi over 2 is right here. and draw a little box around that. So now, if you look at the function that's in there, this little thing, if I turn that sideways, if I reflect it over y equals x, that is a function. So when I do that and reflect it over y equals x, it's going to look like this. So my domain for this function is not all real numbers, because remember the domain and the range switch. So the domain for the inverse is -1 to 1. That's all I can plug into it, because my ratio between the opposite and hypotenuse can only be between -1 and +1. So those are the only numbers that I can plug into it. And then my range, normally it would be all real numbers, but then that gives me not a function. So this is my new range. -π/2 to +π/2. And I guess this should actually be a closed, sorry, these are all brackets up here too. Okay, so there we go. Alright, so that's what the inverse sign looks like, and you can go through and do this with all of the functions, but like I said, I'm not going to spend time doing that right now. If you want to see them, they're on page 51. Right at the top, it's got all 6 of them, and those would be much better than me trying to go through the graphs. So, like I said, there's not going to be any calculus in today's lesson. You are going to have to do a couple of word problems, so I just wanted to remind you real quick about how you do those. So basically with inverse trig, they're going to give you, this is an example, word problems. But they're easier because you don't have to take any derivatives. Alright, so they'll give you something, draw a picture, because you're going to end up making a triangle, and they will tell you 2 side lengths. So they'll say, let's find this angle, and we want this side length to be 11, and this side is going to be 15. So what is theta? So you're going to set, every word problem is going to end up with a triangle that looks something like this. This one, theta is here, I know I have the opposite side, and I have the hypotenuse. They're not always going to give you those 2 sides. But because I have the opposite and the hypotenuse, that should make you think of sine or cosecant. But my calculator has a sine button, so I'm going to use inverse sine. So the inverse sine of the opposite is 11/15 equals theta. You can plug that straight into your calculator. Make sure your mode is in radians. And I know that's a hassle, but go ahead and do it anyways. Alright, so for this one, I'll plug in my calculator, and I don't know how much you can see because it might be kind of glary. But we have inverse sine of 11 divided by 15 equals 0.823, and I'm going to check my mode just to make sure. Yep, it's on radians. Okay, so 0.823 is my angle in radians, and if you wanted to see that in degrees to get a better intuitive sense for what it is, because sometimes it's easier to figure out problems that way, it is about 47 degrees. So this is radians, or 47 degrees. AP exam, they want to see radians though. Okay, and that is it for today.